Hello everyone. Welcome to our class introduction on the machine learning. And my name is Vasan, and you're instructor for machine learning program. Okay. So here we will learn about what is machine learning and what is the definition of machine learning. What we'll see what are the topics we're going to cover. And what do algorithms do, machine algorithm do, and when ML is useful, and what is the history of ML, and what are the prerequisites to in order to become an ML engineer, or wherever you're using the machine learning. In order to learn the machine learning, what are the prerequisites you require? And we'll also see where does we use this machine learning application, right? We also see what are the real world applications, and we see how we define the mind mapping around the machine learning, because there are lots of methodologies, algorithms are available in the machine learning, and we'll see each one by one, and how we're going to learn them. And there's importantly what are all the steps involved in when we are handling the machine learning modeling, and also we'll see what are the important machine learning algorithms, just like we see in the mind mapping. And we'll also see what are the key aspects of a supervised and unsupervised machine learning, and what are the pros and consequences of supervised machine learning and unsupervised learning. Now, without getting delayed, let's go to our machine learning. So just here, according to Advanced ML back in 1959, so machine learning, it's a field of study that gives the computers the ability to learn without being explicitly programmed. What does it mean? It's like now today we see a lot of programs, the software engineers, they do develop the web, or they do work on a lot of software development. So how does machine learning going to help them? Let's say day by day, every day, we do see a lot of steps are iterative, and a lot of things are learned from the experience that we do have, right? So machine learning helps the computers or the machines to learn them from the past experience and try to imitate the same thing, or even you can predict the next nature without being explicitly programmed using some machine learning algorithms. And the field of all these things is nothing but the machine learning, right? So the key idea of machine learning is to, instead of explicitly give the programs to the computer, it tries to learn from the past behaviors or the scenarios or the situations, and ML models or the algorithm try to find the pattern between these observations, and it tries to give out the some output, or it tries to give the performance out. That's what the machine learning all about, right? So when I say a lot of learning process, model based behavior, data transformation, what are all these things actually? How does the learn machine or the computer learns, right? So system try to learn to do the task based on the well defined mathematical methods or statistical methods. So system will learn these things. And what is model based, right? So when you say a lot of time model or these algorithms, what does it mean actually, right? So it's a ability of the machine to do the task based on the given model. So model is nothing but same once again, whatever the representation that in a mathematical expression, and all the data set around the world. So whatever the data that you are generating from the world, you're trying to learn from that, and apply a mathematical expression. Thereby, it tries to understand. Okay, that's all about the model based, and it tries to give the behavior. It tries to represent some form. Output could be in some kind of association, or it could be a pattern, or it could be a relationship between the variables. So it machine learning behaves based on all these things in different formats, right? So the one of the fundamentals that a machine learning do is, it is always data driven. So models are generated from the huge volumes of the data. Without data, it's really impossible to do the machine learning, right? Machine learning processing, right? So you need the rich data for this. And also it's important to understand what is the quality of data that you're having, because if the data is biased, or it has the some kind of missing information, or if it is not processed properly, you'll always end up in the machine learning algorithm bias towards one particular variable. So it's always important to have these, right? So now let's try to understand what does the machine learning algorithm do, right? So one, as I mentioned, one of the important factor in machine learning do is it always finds out the best patterns from the data. So how do you find out the best data from, in the real world application? You use a lot of internet these days. You try to fill out some forms and surveys, and companies get this information. Okay, so they'll always put it in a structured format that machine can understand, and from that data, machine learning algorithm is always try to find out the pattern between those data, right? In either it could be a relation, association, all those things. From the data, the machine learning algorithms will try to do, and they can be in, like I said, association, classes, cycles, any trend. Okay, and with these associations, what does machine learning algorithm do is, with this, how they will try to assign a mathematical expression to these patterns. Okay, that's what the machine learning do, right? So then only you will be able to machine or the human can modify that algorithms to predict the future. So based on the past data only, you will be able to assign the machine algorithm, right? That's what the machine learning algorithms do. And when does the machine learning algorithm useful? You can say, like, you cannot apply every time the machine learning algorithm wherever it uses, right? So it's wherever the human or the program, human intervention requires a lot of effort. So there you will try to use the machine learning algorithms, right? So when the knowledge is, a complex knowledge is required. Let's say, for example, during the natural language processing, it is one of the machine learning technique that is being used in the deep learning animation. So you'll try to understand the image, do the image recognition. Then that requires a lot of huge amount of data, and then you tries to run that program, and then your machine learning is useful. And also there are some dynamic situations. You'll try to forecast some situation. Let's say weather forecasting. Also, it is dynamic and based on the past data and huge data, and you cannot directly program it and directly predict the future, right? So you'll use the machine learning with that. And also there, wherever there is no prior knowledge at all, and you have very unstructured information, and there also you can use the machine learning. And then when you try to predict the hidden information pattern within that data also, then also you will use the hidden machine learning. And also you'll try to, in these days, like genetic engineering, also in the genetic engineering also you're using this. So that's why we're using machine learning. Now let's see what are the impacts aspects of machine learning. So machine learning is the once again part of the data science. And data science here, what I mean to say is, data is the huge volumes of information, and science is nothing but the way it deals with the data and try to predict the some kind of information on the pattern. And machine learning uses this information by predicting, with the patterns, and tries to assign a mathematical expression and tries to find out the next level information. Okay, that is about the machine learning and data science. Now let's hear about the machine learning. Machine learning is not quite new. You do see for the last 1 decade or 2 decades, you see a lot of machine learning, but it is not quite new. It has been there since 1950. It is developed first back in 1950 of the neural network. You can always Google this for the next information. Now let's go back to what are the prerequisites that we required for the machine learning. Machine learning requires always the prior, first and most information is to have the rich data. Without rich data, it's not possible to apply your machine learning models. So you always should have the rich data, whether you're sourcing them from computers or the CRM systems or through surveys, or you're storing that in a data breaks, or everywhere. You need to have the proper data. And after you have the data, what next steps? You should have the basic understanding of how does the maths and statistics to deal with this data. You should have the basic understanding with that. Let's say, for example, mean, mode, and standard deviation. What is covariance? What is the R value? What are the metrics that you're going to all deal with the statistics? So you should have the basic fundamentals of math and statistics. Also, you should have the little programming knowledge. That is like most of the times data science or the machine learning uses Python or Java and Go. So basically, Python is a little essential in these days because with the if you wanted to import the certain libraries which help machine learning algorithms, you don't have to explicitly program it. You just try to download those or import those libraries and put them into in your tool and try to use your mathematical expression so that machine can understand using Python programming. That is mandatory. And the next are the tools that required are Jupyter Notebook or the Kensor or TensorFlow. These are all the libraries that explicitly support machine learning models. And also there are we will teach you about the in detail what tools that we are going to use. These are all the just examples only, but you'll learn them as you go on. And one more requirement is like if you're working in a healthcare sector or if you're working in a real estate, finance, any other wherever you're applying the machine learning, it's good to have the domain expert because the one who deals with the business, and if you also have the understanding about the how to apply this machine learning, they will also win the match, right? So that's where the prerequisite is at. It's good. It's not mandatory because you can sit with the domain expert and try to apply this well, but it's good to have in your bucket. Okay, so this is about the machine learning and prerequisites. Now let's try to see where do we use the machine learning based algorithms. Where do you use that? So there are plenty of algorithms, plenty of applications where you're going to use it. But more importantly, we will discuss only these 8 factors because of the time constraint or the application knowledge that at the moment that is sufficient for you to learn. Because as you go on, you can explore more. But majorly in the finance sector, you will try to use the machine learning models to find out the fraud detection, and also on the sentimental analysis. Sentimental analysis is nothing but whenever a corporate companies try to introduce a new product into the market, they will try to understand how well that model, that product is going to work out. You'll try to do that surveys, and you will try to find out the people response from that. So from that response, you will see how the people are interested towards that product. So machine learning algorithms are useful in this majorly. You'll try to filter a lot of data and process them, and you try to find out the emotional behavior of a human for this product. Okay, and then there's one more important application is credit risk management. So if banks wants to give a credit loan to or credit to any person or through the individuals or the business, they will always evaluate the credit risk of the person. So how do you do that? Based on the CIBIL score, right? So CIBIL score always has multi-factors like how much number of repayments that you have in the past, how many number of credit cards that you have, or any prior loans, short-term loans, or the long-term loans. Always all this the information, and it's not easy for the a person or systems to directly deal that okay, this person is good, but you cannot. So when you apply the machine learning models there, it will try to predict whether the future person in future is going to get default or not, right? So based on the behavior. So that's where you will use, and you'll also to see the in manufacturing sector, you'll try to see the prediction of the equipment failures, and you'll also see the prices of a new houses or dynamic markets, and there also you'll use the machine learning, and you'll also see network intrusion detection whenever some system has been built and firewall is going to break out. So what are the potential possibilities that a firewall is going to break out at one particular situation? So you'll use the machine learning algorithms and to see how the system is weak there. And sometimes you'll also use the pattern for the pattern recognition and image recognition as well. So try to identify the objects, like when you go in front of a face recognition system, to allow you to entry into the airport or into the office, you will try to see the face of a person, and it will detect. And how does it detect whether your person you have the access or not? Then how do you allow it? So using machine learning algorithms. And one more important easily that you can understand is the email filtering. Right now, whatever you see on the your email or something that the mail that you're coming into your bucket, how does it filter out whether they're social networking or the primary information that you're going to get, or is there any spam with that? So all these things, how do you get? Earlier when the Gmail was developed, it's not all the information is categorized there, but now you're able to get all of them, and you're able to see the main information of it. So how does it machine learning algorithm do filter out all these things? So this is how your machine learning algorithms are being used. And so these are all the real world application. Autonomous cost is one of the important application that you do see these days. Also, the speech recognition, and if the person is, whatever these days you do see, like Siri or the Cortana on the Microsoft, all this, how does it recognize a person, right? So based on the machine learning algorithms only, right? And as I expressed, that facial recognition is useful machine learning application. And there are other areas as well, like during the medical image analysis, doctors want to see where does a particular tumor is there. If he wants to do he has to understand a lot of medical image analysis. And for the financial sector, fraud detections, as well as the prediction maintenance in a manufacturing sector. These are all the real world applications. Now let's see one more application. Like, how do you get the recommendations when you open any online e-commerce platform? How does they have the rich data of what you're surfing on the internet or the application? They'll always have the user behavior analysis. Based on that, they will recommend the products based on the search that you have, and they will also see, oh, this cart is empty, been for a while, and how does you're not doing, still you're not placing the order. So they'll try to recommend these things, and on the Gmail as well, as I explained already. And one more important application is, on the Google Maps, when you try to find out the distance from one particular place, other place, and how much the arrival time it is going to take up. So earlier, in olden days, what is the time that is going to take up is like, speed is nothing but distance divided by time. Now, when you time you wanted to predict, so speed time once again distance by speed. That's how you used to. But now, if you wanted to go from Hyderabad to Bangalore, and how does it? There are lots of other factors, like what is the traffic that is going to have, what are the, if is there any maintenance work is going on, a lot of other factors that considers, and try to find out the time it is going to take, right? So that's the application. And I will see what is these things like as we go on in the mind mapping. So this is one of the mind mapping I wanted to explain you for the machine learning. So there are plenty of terminologies that you will come across while dealing with the machine learning. So one of the important things that you're gonna do is the work with the supervised learning algorithms as well as the unsupervised learning algorithms. Okay, so what is supervised learning algorithm is like, majorly it deals with the labeled data or the structured data. Like, you have the enough information is ready, then you'll try to apply that model, and then you'll try to see what is the behavior or what is the accuracy of that. But when it comes to unsupervised learning, you don't have the structured data. You will have random data from the market. From there, you will try to do a lot of iterations and try to structure that data, and then you try to apply that unsupervised learning. Then after that, you will try to still apply the supervised learning. Okay, so that's how you do it. And there are other learnings also, reinforcement learning, which is a combination of both supervised and unsupervised. There are some advanced machine learning algorithms as well. One of the is deep learning, majorly neural networks or the natural language process that you're going to use. Okay, and we'll also see in our course, like how does the evaluation of the metrics will be applied to for each model, for each supervised and unsupervised. You'll also deal with feature engineering, selection, and as well as the optimization techniques, and what are the tools that you're going to use. But though it might seem very confusing for you, but as we go on, you try to learn each algorithm steps, and when you deal with each tool, how you're going to use it. So we will teach you in detail about all these supervised learnings with the theoretical explanation. And at the end of the session, we'll also teach you how you're going to use that using Jupyter Notebook with the programming, and you try to end up with the understanding of how this particular model you are going to use in the real world. Okay, that's how we are going to test. So when it comes to supervised learning algorithms, majorly the regression, there are quietly two types of supervised learning algorithms. So majorly regression and classification. So what is once again regression and the classification is nothing but, regression is nothing but trying to predict one particular output based on the information that you have. Okay, classification is nothing but, once again, based on the information you are not predicting any real number. You're just trying to categorize them into classification, whether this particular more object is belongs to this particular class or not. That's the only thing, right? So for regression, can I say one example? Like you're trying to predict the mileage of the car based on the age of the model of the car and number of cylinders that it have, what is the current displacement that it, all the information you're trying to predict the output as the car mileage. That is one of the primary example for the regression. And for the classification, you will also see other examples like, whether a person is going to be diabetic or not. You'll try to use here logistic regression, whether this particular person is going to be belongs to this particular class or not. With that classification models, you'll see. So you can see this algorithms later, like as we go on, because we'll see in detail about each particular algorithms in detail. So, but for the important factors, we will teach you at the beginning linear regression, what is polynomial, and the regression, and the classification we will teach you in detail about the logistic regression, decision tree, and support vector machine, and random vectors. This is in the supervised learning. And when it comes to unsupervised learning, majorly you will deal with the clustering, and you'll also see what other learnings are PCA, principal component analysis, and you'll also see single value decomposition. Okay, you'll also see these things, and always you will you have one model, and you're after doing all those things, you will have the accuracy or the outputs of the model. But if in order to improve those models, you'll always have certain techniques called optimization techniques. Out of those, like boosting techniques or the strapping techniques that you'll use. So these are the models, and you will evaluate the models with some metrics. You can see that mean squared error or R square, and for the regression, and for the classification, you'll also see F1 score, majorly all those things. But what are the tools that you're going to use for this is majorly Jupyter Notebook, TensorFlow, PyTorch, Scikit-learn, and Keras. Okay, so now let's go and see what how does the application. So there, importantly, I would like to teach you the important steps of a machine learning model, right? So any machine learning model will have these steps, but I will also, it's not specific to supervised learning, but I can say this is more or less same common for any machine learning model, right? So for any machine learning model, if you wanted to apply, you should, like I said, you should have the rich data, right? So you always, before that, for any problem statement, let's say, for example, a particular hotel recently has been with booking, doing a lot of cancellation about their bookings. And I know hotel management wants to see what are the reasons behind it, and they also wanted to improve the business and sales and reduce the inventories, because if someone is canceling at the last minute, and how they're going to accommodate for a new person who's arriving. So you have to see it. So that's a problem statement of a business. And once you know the problem statement, you will find out what are the business requirements, and you'll try to formulate a business details. From that, you'll try to pull out a lot of information from the sources, like if you're using application, mobile application, or if you're using the internet web application, you'll try to pull all those information. So you'll formulate one particular data. So, like I said, machine learning deals with a lot of data, so it requires a lot of information, right? So first and foremost thing that you require is the data. Okay, then whatever the data that you have these days, like it has to be pre-processed. Like I said, even structured data might miss out some data, missing values, or can have the outliers. What you will do is you will try to pre-process the data, and what you will do in the machine learning, supervised machine learning, is that you will try to divide that data into two sets majorly. One is the training data, another is the test data. So whatever the 100, let's say for example, a table has 100 label of information or the objects, and you'll try to divide that table into 70-30% just for generally. You might increase or decrease generally, but there's a general recommendation. You'll try to divide that data into training data set and test data set. And what you'll try to do is, based on the business problem, you'll try to choose the algorithm or the machine learning. Just like, let's say for example, For car mileage, I'm choosing the linear regression model. And if I wanted to find out whether a person is diabetic or belongs to diabetic class or not, I'm going to use the logistic regression model. So similarly for hotel cancellation of that, I wanted to use the decision tree models. So like any models can do, right? So similar, and after you select the algorithms, now you try to apply or fit your algorithms to that training set data, and you try to predict the information for the training data. Whatever you apply the training data, and same thing you'll try to apply it for the building the model, and you'll predict the output of. So whatever the accuracy that you're gonna get at the end of the model training and build the model, that information will be useful in evaluating the test data, right? So the rest of the 30% data that you're going to use it for evaluating the model that you have built on the training data, right? So it might little confusing for you at the beginning, but as we go on, it will be more understanding. So we'll teach you in detail what is all this about when you go on learning about each particular model, right? So once you evaluate the data, what you will do, if you're happy, satisfied with the accuracy of the model or the outputs, you'll try to productionize it, and you'll keep on doing this iteration. But if you don't satisfy with the result, what you're going to do it, you go back. At any stage of the data, if the evaluation test results are not getting, you'll try to increase or decrease the training or model. You'll try to choose a different model based on the analysis. And you'd always go back to once again try to set the different ratio 80-20% of that. All you can always go back to pre-processing data and try to use the generalization techniques there to process that. So any stage it go back. So more or less these steps for the machine learning is quite common for whether you are using supervised or the unsupervised learning, right? So for the unsupervised, only difference that comes here is that similar steps before taking up this, you will try to process. After getting the information, you'll try to process a lot of data. You will make it to little structure, and then you will use the unsupervised learning mechanisms or the models. And then once you have the outputs, you will try to utilize supervised learning. Okay, this is pretty common. Okay, I hope that clears. Okay, and yeah. So now so far we talked about what is supervised, unsupervised, right? So let's go back here. So how do you going to use it? Just for take example, you have cat with the different images, and you have these are all the training. Let's say for example, you have a lot of information that you have. This is the images that you have. Let's say for example, both on the left side and right side, you have cat, you have dog, you have elephant, and you're giving this information to one particular model and saying that, oh, my cat is having different shapes and sitting, sleeping, and seeing, and I'm giving inputs as dog, and elephant and cat as the test data. Whatever the trained data you have there, trying to predict, you have applied one model, and I'm asking you to give predict whether this particular image is cat or with this particular image is dog. So right, so supervised learning model, this particular image, it is trying to predict the image. It's as cat. That's how it works. Now let's see what is the how do we are going to apply unsupervised learning. Okay, like I said, unsupervised learning will be very much unstructured. And just in supervised learning, you will see a cat is sitting, sleeping, all those things. You will always see you can observe it as a cat. But in unsupervised learning, you won't have the data anywhere structured. You will see with lot of random data. So there you will try to apply the unsupervised machine learning such as clustering. What you'll do, you try to cluster out for initially. So there are a lot of data here. How does it go? All of them are animals, right? It tries to cluster out cats. It tries to cluster out elephant. It tries to cluster out dogs. 3 clusters. After getting the clusters, once again, if you wanted to see and put that one particular image and try to predict one particular image or output, what you'll try, once again, you'll have to apply the supervised learning after you categorize this image, and same thing, everything goes same. So you'll get the output. That's how you learn it. Okay, right? So far, these are all about the machine learning, and there are popular machine learning algorithms that are available. One of them is linear regression. It is quite simple, and linear is nothing but you have the rich data points are distributed in um, some graph y versus x, and you will the output model machine learning model will try to draw a graph it fits all those lines, and you'll figure out what is the accuracy of that line or predicted line. Okay, so majorly the applications of the linear regression could be in predicting the prices or predicting any variable. And when it comes to logistic regression as well, these are all quite similar. We'll learn them in detail. What is logistic regression and where it will be used, and we'll also see what is decision trees. How well we're going to use it. Majorly decision trees application is like you wanted to understand the loan defaulters and how you're going to classify them, whether a person is going to defaulter or non-defaulter. So then you'll try to use the decision tree algorithm, and you'll also see clustering, k-means clustering, and GBM. So, like I just did before this, I have shown you a lot of unstructured data. K-means clustering is going to utilize the same way unstructured data and try to clusters of the data, and after that you will try to apply them. So majorly for image segmentation, you will use the clustering models, like you can see right. So here. Also, you will see a lot of improvement models like techniques improvements, right, for the model. So you'll use the gradient boosting method or the stepping method. Majorly, this is used for the predictive analysis or the anomaly prediction. And also, we have the neural networking, majorly used for the natural language processing or the autonomous vehicles, where you will use deep learning techniques majorly. Don't get confused. These are all might look confusing at the beginning, but as we go on, we'll learn them in deeper. Okay. So there are key aspects of supervised and unsupervised learning. The major differences, like you have the structured data, unstructured data, and with the supervised learning, you will only try to classify them, but you or the predict the value in the regression classification. But when it comes to supervised learning, you will see here. You try to find out the hidden patterns that are available in that, and also there are clearly you can see the differences, like how does you'll get the outputs from the supervised and unsupervised learning, and what are the common algorithms that we use in supervising or linear regression, decision trees, and neural networks. And when it comes to unsupervised, you will use clustering and PC and other things. There are practical other examples as well you can see here. Okay. So and then you can clearly see what are the applications as well as the evaluation metrics. Majorly for supervised learning, you will use the F1 score, and for unsupervised learning, you will try to use the Sinhout score or the inertia, other metrics as well. So these are the applications and example. We'll share you the notes once you completed this. So let's see what are the advantages of the machine learning majorly. So machine learning, supervised machine learning always requires the accuracy of the data, and it tries to generalize and it interpret the results easily. And you'll try to do a lot of regression and classification. You do the various type of data and analysis you will do. Always you will try to do the tuning and optimization of the machine. There is always a scope, right? And you will have the well established algorithms which suits the machine the data for the supervised learning, but not every machine supervised learning algorithms will have the advantages, but there are some disadvantages as well, right? you know in order to apply a supervised learning algorithm on a particular data, one of the important factor that it should is it should have the labeled data. Means that information should be in a structure, which should be useful for the training. Otherwise, it's quite difficult to apply the machine learning algorithms. Okay, and one more thing is called the overfitting. There are some terminologies called overfitting, underfitting, and perfect fitting for any particular model. Like you have the rich data, and whatever the machine learning that you are going to apply, if the model is overfitting, and it takes a lot of complex to run that model, right? So that's why overfitting is not always recommended. And so supervised learning will try to overfit the model sometimes because you have the well-established models. and that may be biased towards one particular feature. Okay, there is always limited data might be available in real world. You may not have the structured data directly available on the real world, but yeah, these are other disadvantages. Now let's see what are the advantages of the supervised machine learning algorithms. Majorly, supervised learning algorithm is like no global data is required. If you wanted to apply unsupervised learning, you always have the answer, like to how to deal with this. You may not have at the beginning everything at the moment, but you will try to understand what uh, that data is deals with. Okay, so there are you can see like this is unsupervised learning is applicable, can be applicable to large data, and tries to figure out what is the pattern discovery, what is the dimensional reduction, and if you wanted to find out what is the anomaly identification. And okay, you might spend a lot of data, your time in data preparation in unsupervised learning, because the data is not structured. You will try to put them in some label forms, and then you try to apply the models. Okay, so unsupervised learning always gives the challenge to learn. You'll have to machine data has to always learn and try to predict, apply the best possible machine learning algorithm. That is one. And there are some limitations to this model as well, because the guidance towards the unsupervised learning is always limited. And in order to evaluate them whether your unsupervised model is predicting fine or not, sometimes the metrics that you're going to use may not always optimal. Okay, and the algorithm choice that you're going to is always dependent on the problem. So not for the healthcare sector or for the financial sector, or for the automotive sector, there is always a different algorithm that you're going to use. So these are the majorly unsupervised learning algorithms limitations. Now I hope I covered most of the information that you have. So in upcoming session, we will try to see in detail about what is linear regression under the supervised learning, and what is the logistic regression. We will try to cover on those things in detail. Okay. Yeah. Thank you.